Hi everybody, I'm here today to talk to you about the last line of code and why your API is never actually finished. So when you start thinking about shipping it or putting it out there into the wild, it's probably not quite as done as you might think it is. A little bit about me. My name is Michael Wawra. I'm a developer evangelist for Twilio. If you want to know what a developer evangelist is, apparently you should talk to Tony. It seems to involve a lot of beer from his slides. I love programming, I love APIs. You can find me at these various places. And yeah, if you're not familiar with Twilio, basically we make it very easy for you to send and receive text messages, make and manage telephone calls, and all just done through the cloud. If you'd like to see it working, feel free to SMS anything you like to this number, and if we get a chance at the end of it, we can have a little bit of fun with that. If you do choose to send an SMS message to this number, is anybody doing this, by the way, so I know whether I can jump to the next slide? Okay, fine. What you'll do is you'll just get a very simple SMS message back, and that looks like this. This is the actual Ruby app required to make that response. So it's very, very simple. Now, the reason this is interesting is because as an API company, it's our entire product. Our API is pretty much all we have. When we go out to market, when we go out and do things, our API is, the thing we put forward. And the whole thing really starts off with one of our friends. And I suspect this is a friend to everybody in the room. And if anybody wants to tell me otherwise, then please do so. And this is one of our friends. Does anybody know what this is? It's a URL. Well, you'll know what a URL is. It's very, very simple. It's a resource. It points to a thing. And what it specifically points to is a tweet I wrote expressing my surprise that my hotel served Brooklyn beer, which, Tony can probably tell you again. And it felt like I was in Shoreditch again, or as someone else pointed out on Twitter, Brooklyn. Now, this thing's really cool, right? We pretty much hang everything we do off URLs. There are very few things we do. Does anybody, I know this is a stupid question at an API conference, but does anybody think they write software that runs totally in isolation? Good, I'm in the right room. These things are fantastic. Everybody loves them, they're yummy, they tell us what we need to do, they help us, they allow us to build things, and we have started building this incredible array of products and services based on the internet because we can use these URLs. The problem with them is, despite the fact that they make us feel warm and fuzzy, accessing them can be a bit of a pain if you're not using a web browser. So this is accessing a URL through curl. Specifically, this one is making a post request to Twilio, asking it to send a text message which says, "Jenny, please, I love you." I don't know why that's the sample code, but it is. But there's a bunch of things in there that are interesting. The last line in it is actually the authentication. That's okay, fine, we can cope with that. But if you look at some of the other stuff in there, the third line down where we have body text, it's full of encoding because we have to take what we know how to use and we know how to read, and we have to do stuff with it so that we can send it over the internet and it can get to the right place, be read in the right way, and do the right thing. And actually, it's kind of yucky. Did anybody remember all the details of that? I mean, there were 3 parameters to it, 2 from body, that was it. But there's so much encoding and stuff in there, like, can you remember how to encode the plus symbol before a telephone number? I can't, and I do this for a living. It's crazy. So there's a solution, which is REST. I'm not going to go into hypermedia before anybody asks, but we'll just stick to this as it is at the moment. And REST is awesome. It's been around for a while. We all know how to use it. It allows us to do cool things with URLs that make sense, and it's handy. It's comprehensible. It makes sense, and everything's fine. But this is the Ruby code required to make a post request to one of those URIs. This particular one is to the Rackspace API. I just copied and pasted this from Stack Overflow. And it's what? 8 lines of code. There's a lot of stuff in there, and all it's doing is handling the happy path. If something goes wrong here, there's no code to handle that at all. All we're doing is saying, hey, just make this request and get me some results. It's kind of clunky because, there's a lot of code. Does anybody remember all the details of all of those lines of code? I don't. Now, we're software engineers, right? So we'll abstract. We'll say, well, I'll take that thing, I'll wrap it up in a method, and I'll reuse it. But there's a bunch of other things we need to start thinking about. For example, who can tell me what this is? When you get back this code, it comes with some text, please. Not found. Easy, right? Perfect. Everybody knows it. So if you make a REST request and you make a post request and you get a not found error, fine, we know what to do. Who knows what this is?
Redirect. Temporary redirect.
Temporary redirect. It's actually found. Yeah, that throws me as well. It basically is used as redirect, and that's how we use it by convention. But the actual thing that comes back, if you look at the actual specification, is found. Whereas if you look at this one, this actually is temporary redirect, but no one uses it. Why do we use it? Because we use 302. Okay, here's another question for you. How many HTTP response codes are there? A lot. That's yeah. Anyone want to guess a number? 97. 27. Okay, too low. Too low. Too high. There's 88. And that was just when I sat down yesterday and counted the ones on Wikipedia.
They're including other specs as well, not just HTTP.
There we go. But the point is, when you write your code that's handling all of these requests, you're going to have to start worrying about all of these errors you want to handle. I'm pretty sure everybody in this room knows that they need to worry about what happens when you get a 200, a 404, a 401, a 500, maybe a 301, a 302, because we don't actually remember 307, 308, do we? But it depends. The person who's built this API, well, how have they done it? Like, what codes have they used? How extensively have they used from these 88 possible codes? And the result is that these 8 lines of code that you started out with, well, they can suddenly start looking kind of messy, because you have to deal with all these different things all over the place, all of the different cases, all of the different endpoints you want to handle, and all of the different things that could pretty much come back. And what you end up with is a lot of mess all over your code that you didn't really want in the first place. This, I hope, is the most profound slide you'll see all day, by the way. So aside from handling, all of the different possible things that could happen just with the protocol we're using to make our requests, there's the data problem. So how does your API work? Like, what things does it do? What data is it expecting and in what format? At the beginning, I showed an example of a Twilio request to send a text message. I included in that an encoded plus symbol that prefixed telephone number, because that is the convention for describing telephone numbers. So if you're making these requests yourself, what data formats are you using? Really good example is dates. Like, when you have to send dates to things, like get me all events or all messages or all logs that happened after or before this date. Well, what date format are you going to use? Because there's a bunch of different standards. Maybe you count to 10 in a slightly different way. That's my favorite joke from the whole thing. So there are some different ways your data may work. And what it means is that your users have to go and trawl through your documentation and make sure they understand everything and exactly how this works, and then go and build that with their existing code, whatever languages they're going to use. So the upshot is there are quite a lot of reasons that maybe we want to start thinking about building helper libraries that we want to ship with our API. Because just exposing it as an HTTP resource that people can access and use is fine. Okay, that is a cool thing to do, and we should all be doing it. But sometimes we're just going to need to give them a little bit more help, so that when people do use our API, we know they can get the most out of it, they can do exactly what they want to do, and just make everybody's life a little bit easier. So let's have an example of a pretty good one. This is the Twitter one, and this is pretty much the exact code you would need to tweet "I'm tweeting with a gem," or "I'm tweeting with @gem," onto your Twitter account, assuming you fill in all these credentials. It's Ruby code. All we're doing is we are initializing the helper object, and we are using it to send an update to Twitter. It's incredibly simple. This one isn't written by Twitter, by the way. It's an open source one that I lifted off of GitHub because it's quite a nice one to use. And I think you'd all agree, it's fairly swish. It handles all of those exceptions for us. It wraps up all of that complexity, all of the other things that we don't really want to care about because we just want to get on building our software, building our app, building our code. So assuming you agree with me, okay, I'm going to take that as a yes. What do you decide to do next? Assuming you decide, okay, well, yeah, you know what? Helper library, that does sound like a good idea. I think we should go and build one. Well, how are you going to do it? Well, the first thing you need to do is you're going to have to decide what languages you're going to support. And you have some choices. These are the ones I could do off the top of my head. Anybody know? There are 30 languages here. Anybody reckon they could write a line of code in all of them? Half of them? Ooh, 5 of them? Yeah, there we go. Okay, there's a happy medium between half and 5, I guess. But the problem is, realistically, you're not going to want to write helper libraries in all of them because that way can be quite dangerous. You just don't want to go there. Incidentally, completely unrelated to my talk, I was listening to the radio this morning. I listen to the BBC radio whenever I go anywhere. And they were saying how Toys R Us stores in America have just had to pull all the Breaking Bad action dolls off the shelf because they were selling them with, like little bags of like pretend crystal meth. And it's like, seriously? What? But the good news is you can still buy them on so just Google. Yeah. Anyway, so... well, obviously it depends on your team as to what languages you want to try and support, and here are a few that you may pick. Twilio ourselves, we opt to support 6 languages with our helper libraries. They are Java, C#, Python, Ruby, PHP, and Node. I think there's also one for Salesforce. I've not really played with it myself, but there's stuff we support, and we do that because, well, these are the languages that our customers seem to want to use. We have plenty of other customers using plenty of other languages, and we know that because we can see it happening. We can also see that they will go and contribute open source libraries for us. There's actually quite a few different Twilio libraries in Ruby. There's one that someone wrote in C++. There's one that someone wrote in Go. There's loads of them. I think there's one in Erlang or something. I don't even know why. I don't really understand what Erlang is for. Someone will have to educate me. So how do you decide what your customers are using? How do you decide what you need to do to help your customers? Well, in actual fact, they've already told you, because if your customers are using your API, they are making HTTP requests to your server, and I hope, please, that you are logging a lot of those requests. You know what data is coming in, which means you should be able to get the user agent for those incoming requests and find out what programming languages your users are using to build against your API. And this is going to tell you everything you need to know. It's like, hey, what versions of what languages are still out there and popular? Or like going back to Tony's talk about developer evangelism and communities and stuff, this is also going to tell you which communities you're popular with. Like, hey, let's go and have a look and say, you know what, there's an awful lot of, say, Ruby people using our API. We must be doing good things with the Ruby community. Maybe we should focus on the Python community or something else. Maybe not. Maybe you should carry on focusing on the Ruby community. But it tells you stuff. Because your users are going to tell you everything you ever really need to know. And you do need to know your users. The reason you need to know your users is because if, like us, you're an API company, your users are your customers. Your users are the people who are going to pay you. And if they're not paying you, then you're not in business. Then they're going to tell you exactly what they want. This is essential. The downside is to being an API company that I suspect may be fairly unique to a small group of companies who have particular types of activity, is that your users can do your job. It's pretty unusual that you go and buy something from someone when you could do it yourself, if you think about it. Like, we go to the supermarket and we buy a carton of milk because we don't know how to go and get our own carton of milk. I mean, you might know in theory, but, how do you pasteurize it, all these kind of things, let alone how to keep the cow happy. I mean, your users can do your job. Your users could go and write your API if they really wanted to. The reason they haven't done is because, first of all, they think you're probably going to do a better job, and they don't want to. They want to go and build their own thing. So your users can code and they know what's going on. So you need to respect the fact that they know how to code and work with that. HTTP is language agnostic. It works everywhere, it works with everything, and we can just use it, okay? We can use it for browsing the web, we can use it for making HTTP requests, we can use it for making REST requests, we can use it for making SOAP requests, and we can use it for hacking Snapchat. It just depends what you want to do with it. But your helper libraries can't be like that. Your helper libraries need to be language idiomatic. Because there's no point shipping Python code to a Python developer that looks like Java code. Because the Python developer doesn't care that all of your helper libraries work the same way and look the same. What they care about is that it looks like Python and makes sense to them, or it looks like Ruby and makes sense to that guy. That's what they want. This is an example of Twilio's REST client. This is Python code. You can tell by the from underscore, because from is a reserved keyword in Python. And it's basically creating the REST client, and it's creating a new outbound SMS message. It's Python code. It looks like Python code. Do any Python developers recognize this? Look familiar? Okay. Happy with it? Yep. There we go. This is C# code. Any C# developers in the room? Few more than Python developers, but that's fine. Does this look like C# code to you? I know the using should be further at the top of the file, but you get the idea. And this looks like C# code, right? Because you're going to use the intelligent suggestion thing you have in Visual Studio that's going to tell you what all the parameters are, and you're going to work through it. Whereas, Python developers, well, some of them still write in Vim. They don't have auto suggestions and things like that. So this is C# code that looks like C# code. Then, referring to a talk earlier before lunch, you need to worry about your vocabulary. So what are the terms and phrases that you have inside your API, and do they make sense? Because while you do want your individual helper libraries to be idiomatic to the language they're in, the terms and features that you have in your API, they need to be consistent, because when a developer goes and looks at your documentation, if you suddenly start using different terminology and different phraseology, it's confusing. And it also means that your documentation from one thing can help for another thing, because it's all kind of inter-referenced. And then there's your surface area. If you're going to build a helper library, how much of your API surface area are you going to cover in your helper library? Well, the answer is simple. It's all of it, because why would you take something away? Why would you ship a helper library and say, oh yeah, you can do everything with our API except that bit? You can't do that bit. You have to go and do that yourself with an HTTP request. That makes no sense. So you need to make sure that you cover your whole surface area. Everything your API can do should be inside of your helper library. And whilst I'm on that topic, everything your API can do and that your actual website that goes with it can do, you need to make sure you marry these two things up very, very carefully. For example, at Twilio, I believe the only thing you can't do with our API that you can do on our website is create a new Twilio account, because it doesn't really make sense to be able to create a new account and put in your credit card with an API request, because you can do that once rather than, do it lots and lots of times, like you will be sending a text message or making a telephone call. So knowing how you marry these two things up and making sure that all of that capability and all of that facility is exposed through your API is kind of important. And then keeping it up to date. If you release a new feature and you don't update your helper library, you have some unhappy people, because now they are waiting to use it. Last year or so, Twilio launched MMS on shortcodes, and we've just launched it on US long code telephone numbers. And when our CEO was up on stage, much like this one, saying, hey, I give you MMS, Jeff was probably less dramatic than that. We had guys sitting there waiting to literally push up to GitHub and release the new versions of the libraries, say the developers in the room, if they wanted to, as soon as we said, hey, this is available now, they could pull down the helper library and it was available. They could start using it straight away. Because otherwise you're like saying, this is available now, but you just have to do a bunch of extra stuff so you can use it. Nobody wants that. And I added this slide in the last 20 minutes from Matty's talk, which is making sure that you have tests around your helper libraries, right? If you're going to ship these things, you're going to put them up on the internet, make sure there are tests to go with them to say, hey, everything works and everything's solid. Because obviously, you want to open source them. This is really, really important to me. If you are going to build a helper library, if you're going to write some code and you're going to put it on the internet and expect other people to use it, let people see what's in it. I went to a talk once in the south of France, and a guy was talking about Ruby gems and how you can basically use them to completely annihilate someone's computer. Anybody in here ever installed a Ruby gem? Okay, how many of you have done sudo gem install ever? Okay, right. Do you have any idea what you just did to your computer? Like so bad. I mean, these things can have compiled extensions in them. Basically, it can pull down code, compile it, and then magically execute it with admin permission. Like, no, just don't. So if you can't actually go and unbundle gems and have a look at what's going on the inside of them, this is scary. So for all these reasons and many more for many other languages and all these different things, you've got to open source this stuff. The best bit is if you do open source it, you start getting work for free, because your community will look at things and go, oh, I know how I can make that a bit better. I'm going to change this thing, or I'm going to change this thing. Or maybe I'll add some extra tests. And they're going to start contributing, and your community that you build up around your helper libraries, around your APIs, are going to help you do stuff. So the last line of your API code is actually in your user's app. The last line of your API code should be in the helper library that you ship. It's not that last line of code that actually finishes off that last response you're going to respond to. It's inside that helper library. And the thing is, because it's inside your user's app, you have very little control over it. You wrote it, but you don't entirely know what they're going to be using it for. And your users are always making new apps. At least you hope your users are always making new apps, because if they're not making new apps with your API, you might want to think about what's going on. And that means that your API is never finished, because someone's always building something new with it and adding a new version and doing something else. So basically, your you're never actually done with this. You can't ever really be finished. So long as your business is growing and is a growing concern, you can't stop. So at Twilio, we've added new stuff all the time too. We started out with a voice product, and then we added SMS, and then we added MMS, and we have to keep adding these things. And obviously you can't go back and break things, but you just have to keep maintaining your product goes forward at the same time that your customers are going forward. So again, you'll never really be done building your API. You'll never really be done building your helper library. But on the other hand, I am done, and that's the end of this talk. Thank you very much.